Okay, so today we will be solving an IB Maths AHL past paper question on differential equations. This concept is also quite crucial in the A-level further maths curriculum. So we have been asked to consider the homogeneous differential equation, and we have been given that y equals 2 when x equals 1. And we need to use the substitution y equals vx to solve this equation, giving our answer in the form y squared equals f of x. So with such questions, when we're given the substitution y equals v of x, for instance, our goal should try and get this. Our goal should be to try and get this differential equation to be in terms of just v and x up to a point where we can simplify it as much as possible, and then integrate both sides. So we would be integrating in terms of v on one side of the equation, and then integrating another side of x in terms of x on the other side of the equation, and then essentially try and simplify it as much as possible to get this equation to be in the form y squared equals f of x. So the first step with such questions is we're going to differentiate both sides of this equation over here. So we get dy over dx is equal to, so we use the product rule, so we do v times the derivative of x, which is just 1, so we get v over here, plus x times the derivative of v, which is just dv over dx. It's just implicit differentiation. And now we can substitute this expression over here into dy over dx over here. So then we get v plus x times dv over dx is equal to, and then I've just split this as two fractions over here. So we get y squared over xy minus 2x squared over xy. And then if we simplify this part a little further, we get, once again, v plus x times dv over dx. And then if we use our indices laws, y squared over y is just y, this x remains here. And then x squared over x is just x, so we get minus 2x over y. And now this is where we make use of this substitution to try and get this equation in terms of just v and x. So we know that y equals vx, so if we divide both sides by x, we get v equals y over x. And then if we raise both sides of this equation to the power of negative 1, we get 1 over v is equal to x over y. And then over here we can just substitute y over x. We can basically replace y over x with v over here, and then we can replace this x over y with 1 over v. So we get v plus x times dv over dx is equal to v minus 2 over v. The next step is, so actually if we notice closely over here, if we subtract both sides of this equation from v, then we just get x times dv over dx is equal to negative 2 over v. So we're able to simplify our expression much further, and now it'll be much easier for us to integrate. So now what we can do is cross multiply. So we do v times x dv, that's just vx dv, and then we do dx times negative 2, that gives us negative 2 dx. And our next step over here is that if we divide both sides by x, we get v dv is equal to negative 2 over x dx. So once again, as I mentioned, it's to try and get one side of the equation to be just in terms of v, and the other side to be just in terms of x. So now we're going to go ahead and integrate this to essentially remove the dv and dx, as we're trying to find the equation in the form y squared equals f of x. We're trying to find the original function or equation. So over here, if we integrate both sides, so what I've done over here is, of course, we get the integral of v dv, and then negative 2 over here, that's just a constant, so I'm integrating negative 2 times the integral of 1 over x. So over here we use the power rule for integration. So we add 1 to the power, and then that power goes down. So over here we just get v squared over 2 is equal to negative 2, and then the integral of 1 over x is just modulus of ln of x. We get negative 2 times ln of x, and then we need a constant plus c. We just need to add the constant to one side of the equation. And now we need to figure out what this constant is. So now we make use of this information over here. It is given that y equals 2 and x equals 1. So, but before we do that, we can actually substitute v with y over x over here. So then we get y over x, and this is raised to the power of 2, divided by 2 is equal to negative 2 ln of x. And now we can substitute this information over here. So if we substitute it, we get 2 over here. So we get 2 over 1, x equals 1. So we get 2 over 1 squared. And then 2 squared over 2, that's just 2. And then we plug x equals 1 over here. We get 2. So our overall expression becomes 2 equals negative 2 times ln of 1 plus c. Ln of 1, as we all know, that's just 0. So we get c equals to 2. And now if we go back to our original expression, if we expand this, we get y squared over x squared over 2 is equal to negative 2 ln of x. And then we can substitute our c value, that's just a constant, which we need to add when we're integrating. So we get negative 2 ln of x, modulus of x plus 2. If we simplify this further, this becomes y squared over 2x squared. The right side remains the same. And now if we multiply both sides by 2x squared, this is our final answer. So we get y squared is equal to 2x squared times negative 2 ln of modulus of x plus 2. And that's our solution for part A. So moving on to part B. So for part B, we've been told that the points of zero gradient on the curve y squared equals f of x, which we found earlier, they lie on two straight lines of the form y equals mx, where m is a real number, and we need to find the values of m. So we know that the point of zero gradient, so when we know that we're dealing with point of zero gradient, the first thing we need to do is just equate our gradient function dy over dx to 0. So then we get this. And then if we simplify it further, then we plug this over here. So we get y squared minus 2x squared over xy. Multiplying both sides of this equation gives us y squared minus 2x squared equals 0. And then if we use this identity over here, we can transform this expression into y minus root 2x, root 2 times x, times y plus root 2 times x equals 0. And then if we solve for y, which is what we need, it's a point of zero gradient. So then we get y equals root 2 times x and y equals negative root 2 times x. And now that we have our values for y over here, and we need to find the values of m, y equals mx, that's just m equals plus minus root 2. So that's basically it. So when you see zero gradient, you know that you can just equate the gradient function, which is dy over dx is equal to 0. And we have been told they lie on two straight lines of the form y equals mx. And then if we simplify it further, we should get an expression that is similar to this. And that's just m equals plus minus root 2. And that brings us to the end of this video. And thank you for watching.